We have another well video. There's several for this keyword section. Part 284C3m1b7a10a. Line 22f1fa19c3m1b7a10a. Nanotubes RKKY Sublattice Magnetic Fusion 5G Wow Seti. And this is a keyword research video. It's about magnetic fields and nanotubes. We have some PDFs, science experiment results that were found, and of course these are going to lead up to formulas in the next couple of videos, okay? So there's the alien radio signal there. On November 26th, I was working on the research. Today's November 29th when I'm filming it. The keyword research continues from valence band to electron hole and high temperature semiconductors from previous videos. I better change that to an S because I keep forgetting to do that. Google keywords, magnetic field nanotubes. So magnetic states, and this is a PDF I found, magnetic states of an individual Ni nanotube probe by anisotropic magnetoresistance. There's the name of our scientist that worked on it. 2012, this is brand new. So defined, and this is a quote, defined magnetization states in magnetic nanotubes could be the basic building blocks for future memory elements. So again, when I see basic building blocks and also future, we're looking at future types of inventions and stuff that you can make. To date, it has been extremely challenging to measure the magnetic states at the single nanotube level. We investigate the magnetization states of an individual nanotube by measuring the anisotropic magnetoresistance effect at cryogenic temperature. Depending on the magnitude and direction of the magnetic field, we program the nanotube to be in a vortex or onion-like state near remnants. Okay. There's the article reference. It's from infoscience.epfl.ch. There's the website. The next PDF file is called RKKY Interaction in Carbon Nanotubes and Graphene Nanoribbons. This is brand new, really brand new, see, a week or so ago. So and this is a quote, we studied Rudderman, Kittel, Kasuya, Yozita, RKKY interaction in carbon nanotubes, CNTs, and graphene nanoribbons in the presence of spin-orbit interactions and magnetic fields. For this, we evaluate the static spin susceptibility tensor in real space in various regimes at zero temperature. In metallic CNTs, the RKKY interaction depends strongly on the sublattice and at the Dirac point. Again, remember all those graphs that we saw about 3 videos ago? It was talking about sublattice and Dirac point. So these keywords just keep coming up, okay? And it's purely ferromagnetic. This has come up before. Antiferromagnetic, we got that before too, for the localized spins on the same different sublattice. Whereas in semiconducting CNTs, the spin susceptibility depends only weakly on the sublattice and is dominantly ferromagnetic. The spin-orbit interactions break the SU2 spin symmetry of the system, leading to an anisotropic RKKY interaction of Ising and Moriah Dzalonskinsky form besides the usual isotropic Heisenberg interaction. All these RKKY terms can be made of comparable magnitude by tuning the Fermi level close to the gap induced by the spin-orbit interaction. We further calculate the spin susceptibility also at finite frequencies and thereby obtain the spin noise in real space via the fluctuation dissipation theorem. Okay, that's from RKKY, okay, the website, and rxiv.org. Okay, there's the website address there. Quotes from Wiki. Magnetic confinement fusion is an approach to generating fusion power that uses magnetic fields to confine the hot fusion fuel in the form of a plasma. Magnetic confinement is one of 2 major branches of fusion energy research, the other being inertial confinement fusion. This is my first time hearing about this, so I thought this was really interesting actually. The magnetic approach is more highly developed and is usually considered more promising for energy production. A 500 MW heat generating fusion plant using tokamak magnetic confinement geometry is currently being built in France. See ITER. And that came up as well in earlier videos. I don't know. It was in the lines before line 20, so either between 17 and 20, or it might even be in between 15 and 20. Magnetic confinement fusion attempts to create the conditions needed for fusion energy production by using the electrical conductivity of the plasma to contain it with magnetic fields. The basic concept can be thought of in a fluid picture as a balance between magnetic pressure and plasma pressure, or in terms of individual particles spiraling along magnetic field lines. The pressure achievable is usually on the order of 1 bar with a confinement time up to a few seconds. So according to this, you've only been able to confine your energies for a few seconds, and you've only been able to do your particles for a few seconds. And the whole point of this exercise or research is to find a way to make them last longer so we can study them better. Okay? So in contrast, inertial confinement has a much higher pressure but a much lower confinement time. Most magnetic confinement schemes also have the advantage of being more or less steady state, as opposed to the inherently pulsed operation of inertial confinement. The simplest magnetic configuration is a solenoid, a long cylinder wound with magnetic coils producing a field with the lines of force running parallel to the axis of the cylinder. Such a field would hinder ions and electrons from being lost radially, but not from being lost from the ends of the solenoid. There are two approaches to solving this problem. One is to try to stop up the ends with a magnetic mirror. The other is to eliminate the ends altogether by bending the field lines around to close on themselves. Just so you know, there are several formulas in the WOW data that came up between line 17 and 22 that show you how to make this bendable magnetic mirror. Okay? A simple toroidal field, however, provides poor confinement because the radial gradient of the field strength results in a drift in the direction of the axis. Sorry. November 26, my thoughts. It's too early in the morning. I got marbles in my mouth. So mirrors and solenoid has come up in lines 22, WOW data with the formulas. It also came up earlier. We'll probably do a cross-reference once we're done. Once I get through line 22, I'll probably be doing a lot of cross-referencing, because there's only line 22 to line 27, and then I got to go back and see what, add it all up type thing. Remember, it's all puzzle pieces and we got to put together. So magnetic confinement of fusion energy, interesting, because nuclear fusion formulas keep coming up in lines 21 and 22 as well. Yes, there are nuclear fusion formulas that came up in the WOW data. A magnetic mirror, obsidian and hematite, it magnetizes in electric fields. So I'm going to research more in the next video to see if this is possible. Okay? Thanks for watching.